Forward tipping, fairly obvious. Too far forward, you're going to tip the forklift. Picking up too much, you'll be forward tipping. And in cases like this, we're driving along on level ground, rough terrain forklift, that's what they're made for, and then we just start raising the load, and pretty soon we raised it past our stability triangle, and we'll turn the forklift over. And driving too quickly with the load will make our forklift turn over. So these are things we need to worry about. And backward tipping. If it's a very steep incline, you want to keep your load low as you go up, and as you start to raise it, try to land your load accordingly. Don't just boom up this way and then drive up the hill, because it will turn over. And when they turn over, because it's a triangle, they typically end up on their side. They don't land on their back, they end up on their side because the front of that, because that rear axle pivot point. So the rule of thumb though is if it's a steep incline, and I don't mean a gradual, I mean a steep incline, like sometimes getting into basement mechanical rooms in some of the buildings we construct. You want to back down the hill, because as you go down with your front forward with your load and you touch the brakes, the load will fall off and the forklift tends to tip on itself and you screw everything up. So the best thing to do is take your time to back down into the basement room where you can see the load is safely on the forklift and you won't tip the forklift or lose the load. So keep the forks pointing uphill. Landing loads. We're always seem to be landing a load where employees are up there directing us how to get it. We need sheetrock, we need anything we've got, pallets of this, we need scissors lifts, whatever we're using a forklift to put up in the second, third, and fourth floors of these buildings. So OSHA says the employees within 6 feet of that edge must be protected by falling from guardrails and harnesses, or something like that. Some sort of fall protection. In this particular picture here, we have a 54-foot reach forklift, and when you boom it really out, it's pretty springy. So the forklift operator stayed kind of far from the building because he didn't want it to bash into the 53-foot high parapet because he only had a foot of clearance. The forklift operator sent the laborer up the building, on the downstairs, to get 2 4x4s off the forks so that they could use them on the roof to land an air conditioner. He didn't instruct the employee to get a harness and land it and tie off. So there's a couple of things he could have done. When the employee went up there, and I managed to take this picture, it was when the laborer had crawled over the parapet, which was a pretty high parapet, put his knee on the parapet, his hand on the fork, because the 4x4s were all the way against the back of the forks, and tried to pull them. Now, had he lost his balance, his center of gravity, would have fallen between the forks all the way to the ground, do you think he probably would have died? For sure. Okay, well, maybe significantly screwed up. So this is a bad thing. How could the operator have made it a much safer operation? If he'd have just put 4x4s at the tips of the forks and picked it up really slow, when he got up there, the laborer could have approached the parapet and they were right there, just very close to the parapet. That would have made a huge difference. But this is the kind of thinking that we want you operators to think about. Where are you landing the load, and are you putting anyone at risk? Because it's your job as the operator not to send them the load until they're safe enough to receive it, direct it, or whatever they're doing with you on that. But it's your obligation as the operator to make sure you do not put someone in jeopardy because you're just trying to get the load up there. You need to tell them to stay back, give you time to land it. And so that brings up the idea that I like to use cell phones to direct forklift operations rather than just hand signals, because employees can stay away from the fall hazard outside of the building while the forklift is landing the load. Okay, this picture here, know your weight. How do we know the weights on what comes on a forklift? Well, most things that are shipped in on a pallet are going to weigh less than 4,000 pounds. They're typically put on a truck brought to our job by a smaller forklift in someone's equipment yard or some supplier's yard. So usually those are less than 4,000 pounds. So we typically have 6,000, 8,000, 10,000 pound forklifts. We don't even think about it. We just drive over there and pick them up because you have a big brawny forklift. And so it's made all of you operators think you're good operators. Not really. You just have a huge forklift and a small load, so you don't even think about your load. And that's probably 95% of the stuff we handle daily on a forklift. It's the oddball things like long lengths of rebar, air handlers, air conditioners, transformers, switchgear that may weigh a lot more, and we need to really know what it is going to weigh. So we need to have those weights. Everything that's shipped to our job site has a weight tag, including concrete, pumice block, brick. All that stuff has a weight. We can calculate it. You can call the vendor of it. They'll tell you what it's going to weigh. So we need to know that. We also need to know our load capacities. Our load capacities come from looking at the load chart on each individual forklift. You can pick up more with the outriggers are down than you can without. So you need to know how to read a load chart, and we'll talk about that a little bit later. Let's avoid double-tiered loads. I guarantee you 2 trips with a smaller load is far faster than 1 trip where you get greedy and you have a problem. Example, one of our iron workers was taking this forklift class in one of the towns we were building a school in a few years ago. And immediately afterwards went out and picked up a 900-pound bar joist. Stabbed it through the top cord with a fork, picked it up, and it was a long drive around to get there. And it was kind of a long truss. Kind of drove around, drove up onto the deck, drove forward, and placed it on the 2 beams. Time he lowered it, drove back, and went get another one. His workers had already welded that truss in place. So he's got a pretty good sized forklift. It's a 6,000-pound forklift. So he goes and gets 2 bar joists because, well, time is money, and picks up 2 of them, drives around a long way, drives up on the deck, lands 1, lands 2. Those guys just start working on it, goes around, sees that they already got 1 welder in the next one, so he gets them 3. So what are we up to? We're up to what? 900 times 3, 2,700 pounds. We're 2,700 pounds, and that's what we're picking up. So picks up 3 of them, drives around, boom, 2, 3. He's finished with that row between these 2 beams and columns. But they're working on it. So his boss calls. He's yakking away on the phone with his employer. He goes over the stack and picks up 4 trusses. So we're now in this mode here. 4 trusses. He drives around picking up the 4 trusses, and he's done with this bay. The next bay over, he's going to drive down the concrete and land them like he did before, but that's where the bathrooms go, and all the plumbing pipe is standing up in the concrete slab. So he drives up to the plumbing, booms out, and as it booms out, the trusses, he gets past his tipping point, forklift ends up in this mode. The forks are hanging by the bottom cord of the trusses. They're all bowed. Forklift is in the air. Its safety mechanism senses it's out of kilter. It turns itself off. Now we have a stuck forklift hanging by the trusses. 6 hours later, we managed with scissors lifts and other forklifts to balance that forklift just enough to have the iron workers wiggle the crowbars standing on a little old 8-inch beam, 450 pounds here, 450 inch those trusses. Okay, great time, great risk, enough to clear the fork so that we can lift the forklift up and lower it with another big forklift. So if you ever get into a problem like that, you must tie another machine here. This machine won't start, so that you have to lower it so it won't fall and get into a catapult kind of mode. 6 hours. So we interrupted painters to borrow their equipment. We interrupted the block layer to borrow their equipment. We interrupted the sheetrock guys to borrow their equipment. And the iron workers got nothing done. All because the foreman got greedy. 2 trips is always faster than 1 screwed up trip. Okay, oddball loads, like the I-beam we talked about, the Starbucks fatality, if we kept the forks back, it would not have slid off, bounced off the trailer, and killed the guy. Okay. Secure loose loads, take your time. Scaffolds, door frames, anything that's loose like that. Take your time to put a strap or a rope around them, or a wire. Bundle them up so that they're one unit, not a whole bunch of pieces that can fly all over the place. And then we want to make sure we know what we're going to put our stuff on. Typically this picture looks like the mason putting a pallet of block on their scaffolding. And they need to make sure that they have enough planks, and the planks are rated for it, and that they're near the scaffold upright so they don't have a cracked plank. But in this next picture, this is the iron workers dumping all the bracing that goes between these bridging here to keep it so it is a rigid box so it won't fail. They went up there and they dumped it all on, and of course it failed. So don't overload your work surface. Unbridged bar joists don't hold 3,000 pounds worth of angle iron, right? So they destroyed their own work by being greedy and getting in a hurry, right? So that's the kind of thing we want to make sure about our loads. Okay, and in this picture here, this is a case of a block layer going out too far with a heavier block than he thought. The original block was made of pumice and it weighed 30 to 35 pounds per block, 90 of them in a cube. They changed to a black block made of a different material and it weighed 60 to 65 pounds per block. Not thinking, he picked it up with his 8036 Skytrack, went over, boomed out like he always did, and as he did, he tipped the forklift because it was twice the weight of what he was expecting because he didn't ask what those block weighed. So that forklift operator tipped the forklift and now he's in trouble. He boomed out to get in trouble and he got in further trouble because he boomed back in and subsequently fell and shot block everywhere. What he should have done in this case here is simply lower the load. Had he let the oil out of this cylinder, it would have changed this angle, which would have set that back tire on the ground. So lower the load. Just because you boomed out to get in trouble doesn't mean booming back in will get you out of trouble. That's that intellectual versus panic. So just because you do the opposite of what you did, that's part of that panic. Stop, go back to your intellectual frame of mind. That will keep you out of trouble. Steering. Most extended reach forklifts are equipped with four-wheel steering. Four-wheel steering capability, the operator can choose from two other steering operations. This is four-wheel steering. Very common. Most of you use four-wheel steering all the time and you never think twice about it. These machines have never been switched into anything else. And this is where we can have problems. So we have another steering mode called crab steering. And if you were to do my driving test, I make you become proficient with crab steering. Most of you don't want to use crab steering. You kind of feel like it's uncomfortable, it doesn't work for you, but it's a very effective method. That's why the manufacturers put it on these machines, so that you can go up to a building, crab steer it on the side of the building, shift it. You can stock the whole roof with whatever you want to do without actually having to back up in a traffic lane or something like that. Crab steering is a very valuable tool and you need to learn to use it. And all of you that said you're experts, I bet you're not. If you don't know how to use crab steering, you're not an expert with the machine. You're limiting your potential with that. But from a safety perspective of forklift training, two-wheel steering. Most of you never use two-wheel steering. Here's why we use two-wheel steering.